Morning to everyone on the beginning of the 7th week of the semester, and that was Rolling Stones, I'm assuming still. And you know what cut it was, Ernie? Sway. Okay, I'm not sure I can do much with mathematics there. Sway to algebra. There we go. I returned a quiz to you and some comments about it and some feedback in terms of comments made. One of the things some of you are finding difficult, and that is as you go through the problems, particularly if you do it in the computer, you find you're doing well there, and then when it comes to a quiz or a test, you don't remember as well. And that's been a perennial problem with computerized homework. You spend time on the computer, you're comfortable there, you do it, you do well, and then you come to a quiz in which you're doing it on paper, and in the process, it doesn't go so well. So first observation. Since you're going to have to take quizzes on paper, try doing problems on the text on paper within a time constraint. I'm going to go back to some of the things we talked about in 10. You know that I'm going to give you a problem from each section on the quiz. So if you're going to have to do that, then it might be worthwhile as you're going through those problems to maybe write one or two of them out per section. And once you've done that, then go ahead and in the process, try them at, say, day before, where you maybe have 5 problems written out. You've got one from each section, minimum. Write it out, do it, and I'm hoping that by doing that, you'll go ahead and prepare for the quiz better. Because as it is right now, it is not an uncommon reaction to end up doing not as well on the quiz as that you would have done on the computer. Now I mentioned to you, part of my goal here is to try to have you do more work in addition to the computer. So I'm going to come back to the computer here. This is, give me a moment, Ernie, to get this scrolled down to where I can operate with what I'm doing. This gives you an idea of what I'm doing in 4.4 that we're covering today. Now this is online, and I have problems that you're going to do in the computer, and then problems you're going to hand in tomorrow on paper. So you have a computer portion, and then you have on paper to be turned in. Then, as I scroll down a little bit further, we have problems in applications. I need to just pull this over a little bit. But this is what's set up so far for applications in 4.5, and I'm not sure how hard that's going to be for you. And depending on whether that takes a lot of additional time, I have this as an open possibility of going to 4.5 on that day. Then, the end of the week, we have Chapter 5.1. And all Chapter 5.1 is, and I'm going to slide that over a little bit, it is a review of everything we did in fractions. Now, I think there are 21 problems there. It goes all the way up to number 71. But there's like 21 problems, I believe, in that set, and I'm not sure I'm even going to do more than just a very brief review. It's all of our material from fractions in Math 10. It's something that you should be able to do at this point. And so one thought is look at Section 5.1 this week at a couple times to see if you can feel comfortable with that again. I'm not so naive to think just because we did it before it's at the tip of your fingertips. But I need to know how much trouble we need to review and how much difficulty you have with the problems. The one that I'm most concerned about at the moment would be the word problem, where we have to translate. Now let's go back to the quiz, because some other things I want to say about that. One of the things you've got going for you in computerized homework, you can try it, make a mistake, go back and do it again, correct? Then go back and do it again. And then maybe try another problem. What you aren't doing as well as I'd like is the material where on the quiz you could miss a little All you needed to do was miss one negative sign, one little part, and you end up with a wrong answer. There has to be a little more drill. The mechanics part has to get really comfortable for you. And so to that extent, you need to spend a little bit more time in repetition where you really can do it. It's not enough to be able to do it now. You've got to be able to come back another half hour and do it again. Another day later, do it again. Another week later, do it again. Now, there's a very similar problem in language study, one that I experience. I try to learn another language. And in doing that, I find myself really, in a very quick way, picking up a language for a half hour. 2 hours later, it's gone. And the only way I've ever been able to get around that is to immerse myself where you just have to talk and try to get to the point where you can think in that language. Now, that's a tough one for me. I usually figure I'm making it when I start dreaming in that language and then wake up realizing that I've been speaking in my language, or in my dreams, the language I'm trying to learn. Repetition, folks, you can't just do a few problems, get it, and then walk away from it. If you're having trouble with that, then you're going to have to, in essence, 3 times a day come back to the problems and do that maybe even more often, where you have a single problem or something you just keep coming back to hour after hour after hour until you've used it enough, you quit fighting it. Weekends are tough from the standpoint you've got Saturday and Sunday, and then to try to come back to something. And the only other solution in quizzes is to essentially cram like crazy and hope for the quiz you hold it in your head for 30 minutes and then do it. So it's not a matter of knowing it. It's a matter of being able to do it a little bit under pressure, a little bit in terms of what we would call under stress, if you'll put it that way. Put yourself under stress. I mean, in a sense, you have to go ahead, and in some way, you have to find a way of doing problems in a short period of time and keeping it in your head. Now, part of my hope here is to give you homework that you do on paper that you have to bring in and to start doing that a lot more often, and that's what this assignment today is about. And if that works, I mean, you're going to have to give me some feedback. What helps you? My concern is what I can do to help you retain this in your head, because my optimal goal is not what you do here. It's what you do in the next class. If I do what I'm trying to do and I make it work, you go into an algebra class and you succeed. If I don't, then this has not been what it should be. So you have to give me that feedback and that commitment on your part. If you need more problems, then do more problems. If you need to do more on paper, do more on paper. But somehow or the other, we've got to find a way of pulling this together. And it's got to be a bit of a group dynamic also. We've talked, and for those watching on Palomar, those of you who are watching across the state, because remember we're going out to over 100 colleges. The Bridge program is unique to the extent that it provides support. We do it through tutors. We provide tutorials in the afternoon where you can drop by. But I think the most important thing that came out of our Math 10 program, and it's something that you've been expressing a concern about, and you have shared that with Larita and some of your concerns, and that's the sense of support working together. You're sort of looking from the outside in a little bit what was done before to provide help. May I suggest to you that maybe what you have to do right now is look a little bit from inside out and ask what made the last semester a success. And in large measure, it's because as a group in this program where you were in all your classes together, it became family. And you helped each other, you worked with each other, and you spent time working on problems, not just the problems of math, in every class. And what we're finding now, for a variety of reasons, and I understand their jobs, their activities, you name it, it can get in the way. But what you're losing a little bit as a group is that sense of working together. And to some extent, I can help create it to a bit, but you're going to have to create it among yourselves a little bit more. Getting together, working together, and if it means you find a room where 15 or 20 of you can get together at some time in the day where you just work on problems, then you do it. If it means getting together in an evening at somebody's house doing problems, then do it. Now, one of the reactions from the staff is that this is transition, that you go into an algebra course next, and there is no support mechanism in any sense whatsoever. You won't have all of you in the same group. As much as you may try in your schedules, you'll probably not end up that way. And how you survive at that point is a measure of whether this program has worked in the way we hope. Now, I had to, in process for me as a student, discover that for myself without anybody helping me discover it. And I think quite bluntly, the biggest thing that I had happen to me that was a positive in exactly the same position you're in at this college was finding a group of fellow students who were in the same courses, and every evening we got together. Not at a good time. We had schedule conflicts. We didn't get together until nearly 10 o'clock at night. And then it was 1 o'clock before we were done. But that was every day of the week. Getting together, working on problems, and spending that kind of commitment. That got me through what I think I would not have done as well without. The very, very heavy schedule. But you've got to do something to make that happen, and I can't make it happen for you. We talked about trying to get together as a midterm kind of celebration, and I think that's rather critical, and we're trying to find a time we can do that. But the difference between this semester and last semester is a little bit more what you have to do as individuals, getting together to make that happen, rather than it being forced upon you from the structure outside. And then if you can, and Larita and I talked about this last week, that in response to some comments Brian was giving as a feedback, that Larita had created a small group that she worked with and just got together to keep it together even though the program wasn't going. Now, the expectation of trying to provide Bridge 2, and that's what we talked about in this, is not so much that we simply replicate what Bridge 1 was. That required an enormous number of resources. The Bridge 2 was intended to, one, provide you some continuity from an instructional point of view, from the standpoint of staff, but more importantly, that as a group, you're together, working together, and have some help if you can demonstrate on your end that you've worked together to make it happen. You've been concerned that not enough has been done from the outside. And yet, most of what we're talking about is from what you try to do individually and getting together and making it happen. We try to create some of that with Larita's time before class for an hour. We've tried to do it in the afternoon. Folks, if the afternoon doesn't do it at that hour, find a time that it will, and maybe we can adjust the schedule so that can happen. This quiz didn't go as well as I thought it would. Some scores were lower than they should be. And I think it just boils down to pure and simple. You are not spending enough time on problems. The computerized part is a minimal kind of set. I've indicated to you, you need to double that and spend the time. The success, again, of what we're doing in this pre-algebra rests more on you than anything I can do, Larita can do, or anybody in this staff can do. And it really comes down to how much you want it and how critical it is. This is an opportunity that won't be there again. Okay? It's an opportunity that won't be there next semester. And make it happen. If we could, as a group, commit to trying to make sure every single one of you survives and does well, and that could happen, then we have something we can say was a model of what a Bridge 2 can be across the state of California. As it is right now, we're sort of on that break point. I'm not sure which way it's going, but I'm not very content with where we are today. Okay, so as you do homework tonight, and you do the homework that you're turning in, you also have the part on the computer, and I'll need to have feedback from you. Now, again, a reminder, and I don't know how many times this needs to be reiterated. Fridays, we have a tutorial. You have conflicts, I realize, for some of you. Then Monday, you come in early to get that quiz done that was given on Friday. In some ways, you're working against yourself by not being here during that time. So with all that said, you had 4-3 that you were supposed to have ready for today. Are there questions in that you'd like to discuss? Because we're going into 4-4 next. So this is from 4-3. And in 4-3, let me turn to the page number so we can get that going, because I've been working with some other material. We're on page 260 and 261. These were questions that we had on the quiz. I held you responsible for that. Are there questions from 4-3, page 260, 261, that relate to the computer problems you were doing? Any discussion there? Okay, I've got Emily with a question, Dion with a question. Anybody else? So I have two of you with questions. Okay, we'll take ladies first. Emily? Which problem? You want to just read to me the problem? So you're going to read a problem to me. Okay, so Ernie, I'm going to go to the board with some chalk. And let's go with it, Emily. Do you want to start reading, please? 7x minus 7 12x plus 13. Okay. Now, this problem was a lot easier than what I gave you in the quiz. I gave you fairly difficult level problems from 4.2 and 4.3 in the quiz because we had done so well with them in class. In some ways, I have some question in my mind, should I have maybe taken an easier problem out of one of the two? Debatable. The way your text the computer is set up is to take the smallest number involved with x and subtract it from both sides so you end up with a positive coefficient. So to that extent, this would be adding negative 7x to both sides, or if you want to think of subtracting 7x from both sides. And so if I do that, I have a negative 7 here, I have a 12x here, and I have a plus 13 here. I would like to isolate the x term by itself. So I need to get this 13 away from here. So I can add negative 13 to both sides. And if I added, that'd be 5x, wouldn't it? I, in close enough to the board, saw the 12 and didn't pay any attention to what I was doing. So it should be 5x. Thank you. Now, I want the 13 away. So I'm going to add negative 13 to both sides. So I'll add negative 13. And I'm going to have negative 20 here. And I'm left with 5x here. Then I want x by itself. So I can think of dividing both sides by 5. If I want to get rid of this coefficient, I divide. To get rid of a term, I subtracted. So I'll divide both sides by 5. On the right side I have x, and on the left side I have a negative 4. Because of symmetry, of equality, I can rewrite that with x on the left side, and that's usually done, and a negative 4. Does that answer the question? Right, okay. The comment made trying to get rid of the 7 here instead of the 7x. That is, the whole term involves 7x. Now, I would assume, possibly, that you could have had a misleading visual cue. It's unfortunate that both these were 7s up here, Emily, because if you had 7 and 7 and you saw this one, and then I'll just subtract 7, forgetting that it was this one you're trying to move. Any other questions? Dion, your question now. Okay? Okay. Can you read it to me? 4 plus 17m. Hold on. What's after the m? Minus 2 equals 9m plus 62 minus 7m. Okay, now this is a little more complicated to the extent that you now want to simplify left side and right side. So on the left side, I have what? 17m plus 2. Or you could have written 2 plus 17m. Your choice. On the right side, 2m plus 62. So far, okay? Don't try to move anything until you've simplified. Now, the 2m here, and again, I have indicated to you that I'd like to get to a point where you aren't having to do what I'm doing in this step. But at the same time, I'm afraid of eliminating that step as I explain it. Because now we have a 15m, we have a plus 2, and I have 62 over here. I want to isolate the term with the variable. So if I subtract 2 from both sides, or think of adding negative 2 to both sides, I've got 15m on the left side and 60 on the right side. I want to divide out the 15, and I have m equals 4. Okay, Isaac. Okay, before we go to that, anything yet on, hold on this one? James? Dion, still in this one. The equal sign is establishing it as an equation as opposed to an expression. So again, the key here, I guess, is observe equation observe equal sign. So we have an equation. So the question then, how do we, with an equation, think in terms of solving? What does it mean to solve an equation? So the next question, this is one observed. 2, how do we solve, or how to solve the equation? Well, it helps if I get those e's separated. The equation. Now, part of that, I guess, in an answer is to get the variable by itself on one side. So, well, I wanted to get, okay, I have x, it's going to be on both sides. But get the variable by itself on one side. So on one side only. Now to do that, before we start moving, sort of like note, simplify the expressions on both sides of the equation. So I'm going to say simplify the expressions. Now an expression means you don't have an equal sign with it. So the expressions on both sides of equal sign. Now that's my first priority. So when I came back to this problem, as we slide back over, Ernie, I had a mess equal to a mess. First step, simplify the left expression, simplify the right expression. Forget about the equal sign temporarily. Now that gets me to a new equation, as simple as I can make it, both sides. Then I want the variable on one side only. If you had to make a choice, I'd say go to the left side always. So I wanted all the m's over here. Well, to get all those m's over there, I had to subtract this one because I didn't want it here. How do you get rid of a term you don't want on one side of the equation? Subtract. So I subtracted 2m from both sides. Now I'm halfway there because I don't have the variable over here. But I want just the variable on this side. So I subtract the term to get it away from that side. When I subtracted 2 from both sides, suddenly all I had on the left side was a variable. The constants are on the right side, so I ended up with 15m and a 60. I still don't have the variable by itself. So I can divide to get rid of the factor. I subtracted to get rid of terms. So just a reminder. And Dion's question is at the heart of this entire process. You have to know what you're trying to do. If you don't have a structure, you don't have, this is what I have to do, you're going to sit there nearly in a random sort of way, moving stuff around and hoping something works. So the reminder, subtract terms. Divide factors. Make a bumper sticker and put it on your car. Subtract terms, divide factors. That's what it's about. And get the variable by itself.
So you just trying to replace the
Initial equation by a new equation in each step. So this was my first step. Second step was simplifying it. Third step was to get a new equation. It's called an equivalent one. It'll have the same solution. Then I had to go one more time to finally get it down to the fifth iteration. This is the fifth step in essence. And this equation has a solution because you can eyeball it. What makes m equal 4? When m is 4. You call that a solution. Your question is critical. You've got to know these steps. And the distinction is between an expression. To the left side is an expression. To the right side is an expression. When I say those two are equal, I want you to find me a value of m that makes the left side and the right side the same number. And if you can eyeball that, fine. But if you can't, you have to have a program. And the program, as we slide back over, is this sort of 2 or 3 step process that we're talking about. That, one, observe that you have an equation. If you don't have an equation, don't solve. You just simplify. But if you have an equation, then how do you do it? You want the variable by itself on one side only. That's the goal. How do you do that? Simplify the expression on both sides. Then, subtract terms, divide factors, but you always get the variable by itself first. Divide the last thing you do. That's, in essence, algebra. That's going to be the protocol, if you will, the structure of what you're going to do every problem we get through the semester. It doesn't change. Now, sometimes things look worse before they get better. But for right now, this is what you have to have in your head. You've got to be able to explain to somebody else in that process. Okay? I had two other questions. James? Problem with this one still? You have another one? And Isaac, you had another one?
Yeah.
Okay, are they both? Is yours on 4-3 also? On the quiz? Okay, I'm going to hold off on that for a moment. James? From homework? Okay, let's take the homework. I'll come back to the quiz after we've done the homework problems. Okay, James?
3 open parentheses.
Okay, 3 open parentheses. M minus 21?
Plus 2 open parentheses. M minus 2 close parentheses equals 13.
And that's it? Okay, so I have that equal to 13. I said things have to get worse sometimes before they get better. And this is what I was alluding to. I can't do anything to simplify that left side. I've got to make it worse first. And that often is the case. And then you hope after you make it worse, it'll get a whole lot better. So I'm going to use the distributive property. Now, Dion commented about the language. The language is important to know what the words mean. To distribute, the distributive property means I'm going to multiply this 3 times each part. And some of you on the quiz didn't do that. Now, it may help if you run arrows. At some point, you've got to give up the arrows. Drop that down just a little bit, Ernie, so we can see the arrows. If you would, please, if we can tweak it there. Thank you. Those arrows may help now. Eventually, I want you to be arrow-less. More or less. 3m minus 63 plus 2m minus 4 equals the 13. Now, that made it worse in some ways. But now what am I going to do? Simplify. Combine like terms. So when I do that, hopefully you see 5m minus 67 equals 13. Now, if you make an error up here, you're toast the rest of the way. There's no way of salvaging it. Here, I'm going to add 67 to both sides, and so if I have 5m is equal to 80, correct? And that makes it nice. If I had something other than 80 in the right side, life would not be good. So I want m by itself. 5's a factor. I divide the factor out. So m is 16. Curious, where was the problem? Okay, so you got to here okay, but I wanted the m by itself, so that's where, now, I said subtract the term. I could have subtracted negative 67. That's equivalent to adding 67. So if you were bothered by the fact that, hey, you didn't subtract, well, technically we did, but I'd rather think of it add the inverse. So if I think of adding the inverse to get rid of a term, rather than subtracting, I'd modify that one statement. But most people, I think, follow the guideline of subtracting something out better than they do adding it in to get rid of a term. Yes? But if you brought the 13 over here, I could, and I would have, now watch what happens there. Oh, this I can't pass up. Okay, James, you open the door, and I'm going in. Okay? It's your fault. Just understand this. What James considered doing was to take this 5m up here, and he rewrote it, or was thinking about doing this. Okay. We are very close to the point where this process that I talked about, and I'm going to ask Ernie to go back for a moment, but remember where I said here's how you solve an equation? We're going to change that very, very soon and say set everything equal to 0. Now, distributive property time, my friends. You tell me what goes in the parentheses. Anybody. I took out the greatest common factor of 5. Okay, I've got an m. Good. Minus 16. Excellent. What will make that 0? 16. It's number 5 in the quiz. So again, your intuition is right, because now I have a binomial that's linear. I want to come back to that. I keep forgetting to finish that. I keep wanting to come back. But m, by observation, makes that factor a 0, so the product's 0. So, observation, m equals 16, and you're done. That's another approach. And that's the one we're going to generalize. So, this is where we're headed. This is where we are. Both will work. I guess it's the long answer to James's question. And this was the end of the quiz, in essence, because I had 3 binomials multiplied together. Eyeball it. And I'm assuming if you're sitting back there, Nancy, with that unturned in, just you keep it turned over and don't add anything to it. Okay? Does that answer the question, James? You went a little bit further than I intended, but it's okay. Okay. Still on this, and I guess at this point we have to, because of time, maybe talk about the quiz. So I'll come back, Isaac, to your question, which was number 1, correct? We've got a problem with a box, right? And so if I just briefly draw a box, there's a sketch of a box, and I can put whatever dimensions I want, so I'll just throw something together here for the moment. Maybe this is n here, and let's say this is 2n, and this is n plus 5. And I want the volume. The volume is length times width times height, correct? So the key was to know what your formula is. I'll rotate around now, Ernie, and maybe come over here so I have room to back up this way I'm going. A little bit more. There we go. And now how about just substitution? Now I don't know which one you want to call length, which one you want to call width, which one you want to call height. But in essence, when I substitute here, I'm going to get 2n times n times n plus 5. And just substitute. This is 2n squared. Yes, that's the appropriate response. 2n squared times n plus 5. So I'll write 2n to the second times n plus 5. And in this problem, I would end up with 2n to the third plus 10n squared. I believe we're done. Can you tweak or not? I know that camera's hard to go there. Thank you. Marisol. Took 2n times n.
So what do you do 2n times n?
Wait. This is, whatever my hand is going to get multiplied times n plus 5 with the distributive property. This isn't a binomial times a binomial. This is not FOIL. So I first find this part, which is just a product, which gives me 2n squared. So whatever is there, I multiply times the first and times the second to get the final answer. This isn't FOIL with the binomial. That would be 2n plus something. But if you had 2n plus n in parentheses, you call it 3n. Okay, that is not setting well with you, and I don't know quite what to respond to. The look says not there yet.
I get it.
Okay. Related to this, Bulmara? Okay, I'm still relating to this because I saw a couple other hands start to go up at the same time. Was it on this?
Yes.
Okay. Jessica?
I thought
Once I use the n, not use it again.
Yeah.
That has a poetic sound to it. Remember that if I have a times b plus c, I use the a twice in this what? In the distributive property. I say a times b plus a times c, so I do use it twice. But once I get 2n squared, it's still what? Out in front of the n plus 5. That's where this mess has to be distributed across both those in the sum. You're welcome. Anybody else there in the same? Michael, in the same thing?
Yeah, you'll never try to multiply the n plus 5.
You again are trying to think in terms of FOIL.
Well, no, just rearranging it a different way to multiply.
Okay, let me come to the sideboard. Ernie, will you just bring camera 1 over here? We're having problems with a very important concept here, and it's one that's causing at least 3 of you trouble. So Ernie, as soon as you have that in camera, there we go. I'm going to walk off camera here. You ready to come over here? Here's a problem that we've had before. 7 times 8 times 9. Okay? Now, it's basically what we're talking about. And when you do this, you don't take 7 times 8 and then 7 times 9. You get the 7 times 8 and call it 56, and then you multiply by 9, correct? Okay, so I have 2n times some garbage, which happens to be n plus 5. Now, if I'm going to do the same idea, you multiply these two together and then multiply by 9, correct? So I'm going to multiply these two together, which is 2n squared, parentheses, times this, just like I did there. Now, in this case, it was arithmetic. But the minute I get this is like A, this is like B, and plus C. So whatever is in front, I distribute across in that way. So that says 2n squared times n plus 2n squared times 5, Michael.
Let's say that you had, just when you're writing the problem down, you put that n plus 5 in front.
Okay, so let's say I had this. If you wanted, just like coming back to here, I could have said, I'll do this first. You're going to get the same answer, right? 8 times 9 was 72. And I can multiply that. So if you wanted to and said, okay, I'm going to do this first. Okay, you're welcome to. 2n squared plus 10n. Still have an n out in front. So that's 2n cubed plus 10n squared. I believe that's the same answer we got before, is it not? Okay. Yeah, that's a choice you have. Now I had to do twice there, right? Whereas here, I did it only once. I would prefer simplify the monomial, then multiply once with the distributive property. Is that answering the question you had? Okay. Anybody else on that one? You want to put this over here now. Are you allowed to do that? Give me an argument. Yes or no, and why? Yes, they should be. Why? By what property? It's not the distributive, and it involves multiplication. Which property of multiplication? Community property of multiplication. Yes! You get the trip to Salida. Now, you can do it. Does it change it? No. Okay, Isaac. Your question from the quiz.
Another one?
Yeah.
5x minus open parentheses 3x minus 4.
5x, open parentheses,
Yeah. 3x minus 4.
3x minus 4. Something doesn't seem right here.
Hold up. My bad, yeah. Subtract
Ah, okay.
between
5x, right? So 5x minus. Okay, continue.
equals to 7x minus open parentheses x plus 8.
Okay, here's where most of you bought this one with the minus signs. Okay, so Nancy, again, you don't get to change anything. You just live with what you got.
When you're not looking,
So I've got 5x minus 3x. Then what has to happen? This is where some of you lost it. A plus 4. Now, if this bugs you, make it minus 1. Minus 1 times each of these two. Then the same thing happens over here, minus x minus 8. A lot of you have plus 8. That's where you lost it. Okay? So at this point, if you got that part, the rest went pretty fast. Most of you lost it on this minus sign. Then from there, this became 4x, this became 12, this became x, this became 3, and you're done. Okay, enough with that. I'm watching that clock and expressing some concern. Okay. We're moving on. All we are doing here is translating in section 4.4. Now I'm going to go to some problems. I am skipping some of the material that is involved in 4.4 as far as some of the examples. But the key here is simply to create from simple problems, translation, and then if it's an equation, you solve. So as I look at the exercises, and I've got to be very careful what I look at because some of them I'm going to have you doing, but I'm going to look at number 12. Well, the odd ones are, that's right, you're going to do those on, sorry about that, was a good suggestion, Jessica. Okay, number 7. You're going to do this in the computer, so as we come to the document camp. It says a number. Okay, what does a number mean? Any real number. X increased by, translation, plus. So a number increased by, I guess I'm at 9 is what I'm looking at. A number increased by 17. So that's going to be x plus 17. Is means equal sign negative 8. Listen and watch, because if you don't and you end up fighting this in your own, I don't have much sympathy at that point. Simple translation. Get the equation, and will you please not do this silly semicolon? You get me a new line. I see semicolons in anything you hand in, and I'm going to X you out. Okay, let's go down to what I think is number. It says a number multiplied. This is 13. A number multiplied by 9. Now, why do you have to go to B? What's wrong with X or Z or Y? You don't have to do this silliness. X is a perfectly good variable. 9 times X means a number multiplied by 9. Remember, that's a real number. And my guess is this is going to say the result is negative 36. Yes, is negative 36. Not bad, right? Off there. Let's go to something a little more difficult. 25. 6 times x. Now, you could have said there, 6 times a number. Plus 5 times, now notice where you see the difference. Where it says difference, that means parentheses. So it's the difference of what? Question? When it says 5 times the difference, that means you're going to subtract something. Okay. So notice how that's written with the 5. Then the difference is in parentheses, x minus 7. And it says that sum, referring to your first term, which was 6x, this product, that sum is what? 19. Now, I missed something there. I'm just wanting to read, is 19 minus, there we go, the sum of what? X and 6. So the question, as we come off there for a moment, lots of words lead to confusion, right? So how do we get rid of the confusion? Well, let's see if I can get to where I want there. Okay. I'm going to take some cards. And it's sort of like, okay, if you're bothered by all the garbage, bring it down to that much. 6 times x, that's 6x, correct? Then if I slide the card over, plus, well, that means I have to have a plus sign, correct? Now let's see what comes next. Plus 5 times something. So you can have a 5 and a dot or a parentheses. And it's going to be 5 times what? The difference. Now how do we translate difference? That means something subtracted. That has to go in parentheses. Then you come down to the line is equal to, and then if I wanted, I could say, okay, it's is equal to, that's the equal sign. Then 19 minus means subtract, but notice you don't have all the other garbage there. Minus the sum. Whenever you see the word sum, you're going to replace it with a pair of parentheses. Just like when you saw difference with a pair of parentheses. Now, bottom line, when you get this right to here, that's where you were in all the questions you've asked today. How do I take that and solve it? So if you can get that far, I'm assuming you can solve what you get. So there are 2 steps here. Convert a verbal statement into what? An equation. How do I solve an equation? We went through that for the first 40 minutes this morning. So your big problem here is translation. You've got 7 of these on the computer. You have 7 of them for homework. In each problem you do for homework, I want you to tell me what your variable is. In most of these, it's going to be a number. So you write your first phrase, let x equal a number. Now, we anticipate getting integers for our answers because that's where we are right now. Next week, we'll get fractions. And after that, decimals that aren't fractions sometimes, like square roots of things. Ernie, I've run out of time. I don't think I've run out of problems, but I have run out of time. So if you'd be kind enough to tell me what you're going to select. You got to move. I don't know. I think we're in the right spot. So we'll move on into more things with fractions. So with that, have a great morning.